morning friends. Today we are going to start the next topic from the standard 12, that is oscillation. Friends, when we are going to study about the topic oscillation, we should in our day-to-day life we see different examples regarding the oscillation. Out of that, one example, simple example, you should always remember is of the simple pendulum. Here, if we take a pendulum, then it will move to the left, it will again move towards the right. So here I have considered 3 points A, B, C. Out of this, B is a midpoint. From A to B, B to C, again from C to B, and B to A. Out of this, B is a midpoint. So what is oscillation? The motion of a particle about its mean position is known as oscillation. So, and that motion is known as a oscillatory motion. The example of the oscillatory motion is a simple pendulum. Again, if we watch the middle of the sewing machine, that is moving up and down. So the up and down, to and fro, these are the motions about its mean position. So they are also known as a oscillatory motion. So remember, when we are saying about the oscillation motion, then it is not only left and right, it may be also in the format of the up and down. So what is oscillation? The motion of a particle about its mean position is known as oscillation. Example, the motion of a simple pendulum. Or in different word, you can write the to and fro, up and down motion of a particle about its mean position is known as oscillation. So this is regarding the introductory part. In your textbook regarding the simple pendulum and various examples regarding the oscillations are given. Friends, next part is the explanation of the periodic motion. Oscillatory motion is also known as a periodic motion. So when we are saying about the periodic, so what is meaning of the periodic? Again, we will go to the simple pendulum. Here you can observe that initially the particle is at point A, then we go to the B, then C, again from C, B, A, again it will go A, B, C. So it will follow the same path again and again. So any motion which repeats itself after definite interval of time is called a periodic motion. So oscillatory motion is an example of periodic motion. Again in the topic rotational dynamics, we have studied about the circular motion. The circular motion is also the periodic motion. Friends, remember, every oscillatory motion is periodic, but every periodic motion is not oscillatory. So here, when we are saying that the oscillation motion, then it is following the same path. But when we are saying about the circular motion is also periodic, but it is not oscillatory because it is not about its mean position. So friends, remember that every oscillatory motion is a periodic, but every periodic motion is not oscillatory. So what is a periodic motion? Any motion which repeats itself after definite interval of time is called as a periodic motion. So generally, in the oscillatory motion, we are showing the period of oscillation with the symbol capital T, and the SI unit is the second. If you want to learn about the frequency, so the frequency generally we are denoting with the symbol N. So we have already seen N is equal to 1 upon T. And regarding the oscillation, how we can define the frequency? The number of oscillations completed by the particle in 1 second is known as frequency for oscillatory motion. What is the period? The time taken by the particle to complete one oscillation is known as a period. So particle move from A to B, B to C, from C to B, and again A. So that total interval is known as a period. So what we should know regarding the periodic motion? So any motion which repeats itself after equal interval of time is known as a periodic motion. So oscillatory motion is periodic motion. Let's here we have seen again important thing that every oscillatory motion is a periodic, but every periodic motion may not be oscillatory. Again, we also know what is the difference of the period. The time taken by the particle to complete one oscillation is known as the period, and the reciprocal of period is known as the frequency. Or we can write the number of oscillations completed by the particle in 1 second is known as a frequency. So these are the important terms which we should remember. Friends, the point which I have written that you have to write in your notes. Next part from this topic is a linear S.H.M. S.H.M means simple harmonic motion. In order to get the clear idea of the simple harmonic motion, here three diagrams are drawn. So here in the first diagram you can observe that there is one spring having the specific mass which is attached here. So here no force is acting, it will be at the rest position. So force will be the zero. In second situation you can observe that there is a block and the force is applied in the upward direction. So when we are applying the force, at that time the body will be called displacer at toward the distance x. Friends, the inward force is applied. After that, when we release the force, so again here the direction of F you can observe. So that force is called the restoring force. When the force is applied and when we are releasing, then another force is created, that is called the restoring force. And here we are going to see the relation between the restoring force and the displacement. So what is the direction of the restoring force? In the outward direction. And what is the direction of the displacement? In the inward direction. So restoring force. So remember, force and restoring force, these are the two different concepts. Force which we are applying and restoring force, the force given by the body. So here we have applied initially the internal force. After that, when the body have covered the displacement x, and when the block is released, the block will move in the outward direction due to the restoring force in the spring. So remember, the restoring force and the displacement both have opposite direction. So here we can say that in your block it is observed that the restoring force is directed in the outward direction while the displacement will be the inward direction. In figure 3, you can observe that the block is stretched in the outward direction. So its displacement will be here. You can say that from the mean position the displacement will be x. And when the block is released, then the restoring force will move in this direction, opposite direction. So here the motion is in the straight line, and here the particles will be on the left side as well as the right side, or you can say it is going to and fro. So such kind of the motion is known as a simple harmonic motion. Friends, here is one relation between the force and the displacement. That the force and displacement both are in the opposite direction. So for the linear S.H.M, we can say that the F directly proportional to x, and F is equals to minus k into x. Right? What does the negative sign indicate? The negative sign indicate that the restoring force and the displacement have the opposite direction. So friends, that explanation you have to write in your own words. I am just writing the mathematical part. So F is equals to minus k into x, where the force and the displacement are in the opposite direction. That's why we have applied the negative sign. Where what is the meaning of k? K is known as the force constant. Now in magnitude form, in magnitude, when we are taking the magnitude, at that time we should remove the negative sign. F is equals to k into x. Force is equals to k into x, and what is the value of k? K is equals to F upon x, where k is known as the force constant. So again I am going to explain this equation. F directly proportional to the x, F is equals to minus kx, where k is known as the force constant. The negative sign indicate that force means the restoring force and the displacement both are in the opposite direction. So from this, when we are writing the magnitude form, then friends remember we have to remove the negative sign. So if the negative sign is removed, then we are getting the equation F is equals to kx, therefore k is equals to F upon x. So what is the formula for the force constant? K is equals to F upon x. What will be its SI unit? So its SI unit is, what is the essence of force? Newton. What is the essence of displacement? Meter. So Newton per meter is the SI unit of the force constant. This formula is useful while solving the numericals. So based on this, there is a definition of the linear S.H.M, linear simple harmonic motion. So linear SHM can be defined as the linear periodic motion. Linear SHM can be defined as the linear periodic motion of a body in which the force is always directed towards the mean position. This force is directed towards the mean position. Here is also the force which is directed towards the mean position, and the magnitude is proportional to the displacement from the mean position. So in simple word, we can say the linear SHM can be defined as the periodic motion in which the force is directly proportional to the displacement from its mean position. So friends, the direction of the force is towards the mean position, that is mentioned here, and the displacement is also from the mean position. So the motion, again we can say that the linear SHM is nothing but the oscillatory motion because it is about the mean position. Again, I am going to explain this part. From this block, we can say F directly proportional to x, F is equal to minus kx, where k is equal to force constant. So in magnitude format, we should think with the negative sign. So k is equal to F upon x, that is a formula for the force constant. The SI unit of the force constant is a Newton per meter. Again, there is a definition of the linear SHM. During the examination, the question may be asked, define linear SHM. The linear SHM can be defined as a linear periodic motion of a body in which the force is always directed towards the mean position and its magnitude is proportional to the displacement from the mean position. This is the definition of linear SHM. Next point which we are going to see from this topic is the differential equation of SHM. So friends, this is the mathematical part. This question will be asked for the 2 marks. So the question will be asked, obtain the differential equation of linear SHM. So using the definition of the SHM, we have to derive the equation. So according to the definition of linear SHM, F is equals to minus k into x, equation number 1. Right? F is equals to minus k into x. This we have seen here. According to Newton's second law, according to Newton's second law, what is the rate of force? F is equals to mk. Force is equals to mass into acceleration. According to the definition of the linear SHM, F is equals to minus kx. According to the Newton's second law, F is equals to mk. So compare these two forces. So we can write here ma is equals to minus k into x. Where n is the mass, a is the acceleration, k is the force constant, and x is the displacement. But what is the acceleration? But a is equals to d2x upon dt square. Second derivative of displacement is nothing but the acceleration. So it will become m d2x upon dt square is equals to minus k into x. So take m on this side. So d2x upon dt square is equals to minus k upon m x. Take on the LHS side d2x upon dt square plus k upon m into x is equals to 0. So this is one format of the differential equation. But k upon m is equals to omega square. So this equation will be again get modified as d2x upon dt square plus omega square x is equals to 0. So this is the differential equation of linear SHM. The question may be asked for the 2 marks during the examination. Obtain the differential equation of SHM. Again, I am going to repeat this part. According to the definition of the linear SHM, F is equals to minus kx, equation number 1. According to the Newton's second law, F is equals to ma. So from equation 1 and 2, we have to equate these two. So you can write here from equation 1 and 2, we have to equate both the forces. So ma is equals to minus k into x But what is the A? A is the acceleration. Acceleration is d2x upon dt square. So m d2x upon dt square is equals to minus kx divided with the m. So d2x upon dt square is equals to minus k upon m into x. Again, this minus will become plus. So d2x upon dt square plus k upon m into x is equals to 0. But k upon m is nothing but omega square. Therefore, d2x upon dt square plus omega square into x is equals to 0. So this is the differential equation of linear S.H.M. So friends, today we have started one of the important topic from the standard 12, that is oscillation. In that we have studied the introductory part. After that we have studied what is the meaning of the periodic motion. Then we have studied the linear S.H.M, its definition, an important formula for the force constant, that is k is equals to f upon x. And then we have studied the differential equation of linear S.H.M, that is d2x upon dt square plus omega square x plus omega square into x is equals to 0. Friends, make the note properly. Thank you. Have a nice day.